All right, everybody. So with this lesson, it starts our new and our last unit. Okay, we are going to finish out with this unit till the rest of the year. And this unit is all about exponents and logs. Okay, but before we can get into any real work with exponents and real work with logs, we have to learn all about the properties. Okay, properties of exponents. These are super important. And what we're going to do today is go over some definitions of the properties and some examples, okay? Not much math really is going on, but more of learning what each property means, okay? So the first thing I want you to do, we're going to go through each one. I would like you to put a 1, a 2, and so on in these boxes. You'll see why later on, okay? So the first rule we're going to learn about is called the negative exponents property, which is also known as the elevator rule, okay? And the definition of the negative exponent is any number except 0 raised to a negative exponent is equal to the reciprocal of the number, okay? And a reciprocal is just means to flip something. So, for example, if I had 1 over 5, the reciprocal of 1 over 5 would be 5 over 1. So the top becomes the bottom and the bottom becomes the top, okay? And an example of this would be something like 5 to the negative 2. And how we would use this property is you could see that from here, it now becomes 1 over what was ever here. So this problem will now become 1 over 5 squared. Notice that in this little algebraic definition, the negative now turns into a positive. Okay, so now we have 5 to the negative 2 equals the reciprocal, which makes it 1 over 5 squared. Okay, and this can be reduced to 1 over 25. All right. Now we have some more practice problems here, okay? We have x to the negative third. So now this becomes 1 over x to the third, okay? So that just becomes the bottom. Noticing we don't want the negative. So this is what the property does, is just drops the negative, okay? And puts it below. In some cases, like this one, it may be opposite, where we already have it as 1 over 2 to the negative 3. But we still have a negative. We don't want that negative. So now we just need to do the opposite, where we're going to bring the bottom to the top. So now it's going to become 2 cubed all over 1, which just is 2 cubed, which just is 8. Okay? So the negative exponent rule just flip-flops what's on top and what's on bottom. Okay? So that's one property. The next property is the product of two powers with equal bases. And that definition is when multiplying two terms with the same base, you add the exponents. So anything I underline is important, so you should underline that as well when taking your notes, okay? So in this example, here, the algebraic definition, we have two numbers, which would be x and x, that are the same, okay? All that means is that we can add our exponents together. So an example of something like this would be 8 squared times 8 to the 5th, okay? And with this property, we can add our exponents, so 2 plus 5, which gets us 8 to the 7th. Okay, I'm going to leave it like that because 8 to the 7th is going to be some big some big number. Okay, and I don't really need to worry about that. I just want to worry about the property. Okay, so in this practice, same thing. We have x cubed times x fifth. So the same base, we can add the exponents, which gets us x to the 8th. Okay, moving on. We have the quotient of two powers with equal bases. So this is the same thing as the one above, just with division. So when dividing two terms with the same base, subtract the exponents, okay? So rather than now adding, we are just going to subtract. Okay? And an example of something like this would look like 2 to the 6th all over 2 squared. Okay? Where we can just subtract our exponents. So we have now 6 minus 2, which gives me 2 to the 4th. Okay? We can do that out, but like I said, it's not that big of a deal. So you're just going to keep it like that. Okay? Then we're going to work on some practice problems. Okay? And the first one, we are going to do the same exact thing, right? We have x to the 7th all over x squared. So what we can do is we can subtract those exponents, okay, to give us x to the 5th. Now, the bottom one's a little bit different, okay? You're still going to subtract. You're still going to subtract the exponents, but now your answer is going to be a little different, right? Because now we have x2 minus 7, which gives me x to the negative 5th. And if you don't remember, about 2 minutes ago, we learned what we can do when we have a negative exponent, okay? And if you remember, when we have a negative exponent, we can use the reciprocal. So my end answer here would be 1x to the 5th. 1 over x to the 5th. Okay? So that example had two properties. It had the quotient of 2 powers, and then the answer, we had to go again and use the negative exponent rule. Okay? Now, with the power of a power, this definition is when a term is raised to a power that is raised to another power, you multiply the exponents. Okay? So when you see 2 exponents, you know that you can multiply them immediately. All right? And an example of this would be something like 6 to the 4th, where we see 2 exponents here. Okay? And when we have 2 exponents, we know from this property that we can just multiply them. Okay? And 4 times 4 just gives me 16. And you can keep it like that because you'd get some crazy number. Unless you have a calculator, then you could do it out. Okay? On the practice problem now, we have x to the 5th, and that whole term is then cubed. Okay, so we can multiply our exponents. So I have x to the 5th times x to the 5th times 3, sorry. And this just gets me x to the 15th. Okay? All right, I'm going to go ahead, and this was property number 4. So go ahead and label for that property number 4. All right, moving on to the next. So here, I have the power of a product, okay? And this definition is if you have a product of terms raised to a power, you raise each term to that power. Okay, so here you can see if there's 2 terms within a parentheses and it's raised to a power, we could split them up and raise them both to that same power. So an example of this would be 10y squared, where 10 is being multiplied by y while both are being squared. So we can just break this down into 10 squared times y squared. And I can do this out because I know 10 squared is 100 and y squared would just stay the same. Okay? Then moving on to the practice problem, I have 3 times x squared, so I'm going to split that up to 3 squared times x squared. And I know that 3 squared is 9 and x squared will stay the same. okay? Now I have the power of a quotient, okay? And this is if you have a quotient of terms that is raised to a power, you raise each term to that power. So the same thing, but just now with division. Okay? And an example of this would be something like 5 over x squared, where the whole division, the whole quotient example is being squared. So same thing as multiplication, you can just break it down into 5 squared all over x squared. Okay, where the top would then be 25 all over x squared. Then we're going to do the same exact thing with the practice problem. We could break this down into x squared all over 4 squared, which would give me x squared divided by 16. And this top one was property 5, and this top one was and the bottom one was property 6. Okay? All right, moving on to the last property, which is called the zero power property. Do not get this mixed up with the zero product property, right? Because this is all about exponents. So this definition is any number, this is the easiest one, except 0 raised to the power of 0 is 1. Okay, so anytime you have anything raised to the 0, the answer is just going to be 1. And an example of this would be like 17x to the 0, where the whole term is raised to 0, so it's just equal to 1. Same thing here. Even though there's all this crap and there's an exponent of 3, you still have this exponent of 0, so it's just going to be 1. Okay? So those are all your properties. So those are super, super important, okay? So now what you're going to do is you're going to use all of those definitions to do some practice problems. Down at the bottom, you're not going to do 4, 5, and 6, okay? We're just going to focus on 1, 2, and 3 together right now, okay? So what I would do here is, on this first example, I see that both terms have the same base and that they're being multiplied. So I'm going to go back into all my definitions that I just looked over, and I'm going to realize that the property that I'm using here was property number 2 that you learned, okay? So what you're going to do is you're going to put a little 2 and circle it. So I know that you used the right property, okay? And then I'm going to actually do the property out. So this is this is the property number 2, which is the product of 2 powers with equal bases, where when I have 2 numbers being multiplied with the same base, I could add the exponents. So I have 2 cubed plus 2, because I'm adding the exponents, okay? And this would just get me 2 to the 5th, and that would be my answer. Okay? Then I'm going to move on to the next one. I see here that I have 2 terms with the same base, but they're being divided. So I know that this is the third property that we learned, which is just quotient of 2 powers with equal bases. And with this property, I know that I could just subtract my exponents. So here I'm going to have 3 to the 7th minus 5, which just gives me 3 squared, which just gives me 9. Okay? And the last one that I see here, I see 2 exponents, so that's going to help me, right? Because when I see 2 exponents, I immediately know that it's a power to a power, and that was the property number 4, right? And when I have 2 exponents, what I can do is just multiply them. So keep the same base and multiply them. So this would be 2 to the 6th. Okay? So those notes, those definitions are super important because you're going to need them in order to help you solve the next few problems. Okay? So we're not going to do 4, 5, and 6 at the bottom here, but we are going to do some examples on the next page. Okay? So it is your responsibility to complete these 20. Okay? And what I want from you is the work, and you're going to tell me, so 1 is the property you used, the number of the property that you used, so that's why number of the property That's why we labeled them 1 through 7, okay? And then the work, any work needed. Some of these you'll just notice you don't need to give me the work. You could just give me the answer. But if you need the work, you can show it. Okay, but big thing is I need the number of the property. Okay? So if you have any questions, please let me know. I am here to help. All right, see you later.